Well, hello and welcome back. We're going to continue our study of atomic structure, which, if I could put it simply, is just understanding how all the stuff in the universe is put together on the very smallest level. Everything we know is made of these things called atoms. And there's all kinds of different atoms. And so we've seen the parts and pieces that make up atoms. And now what we're going to do today is look at how to name all the different atoms. Because obviously you don't want to go around trying to figure out what things are based on a drawing or a diagram that you'd have to do. So, just kind of like people, we don't identify with what our face looks like. We each have a name, right? And so usually the name of a person, everybody kind of knows who that person is. Now, every now and then you'll get a real common name like John Smith, and there could be a lot of John Smiths even in this school. But maybe the middle name identifies more uniquely. So maybe there's a Jonathan William Smith, but there could even be more than one of those too, right? So we're just going to try to figure out how to give every atom a unique name so that its name is identical only to the atoms that are just like it, okay? So you got to understand that even though there's no two people that are alike, there are atoms that are alike, okay? So if they're alike, we want to make sure they have the same name. So I'll give you an example. Here's the drawing we had from the other day, right? We were talking about how to draw a Bohr model for something with these particles in it, 20 protons, 19 neutrons, and 20 electrons. Well, it turns out that all the atoms that are like that in the universe have the same name. So I'm going to teach you how to name that, okay? All right, so if you don't already have your notebook out and something to write with, this would be a good time to pause so that you can get everything ready as we get started. You can also see I gave a little heading. I try to do that so that when I send you back at some point to your notes, maybe I'll say, hey, refer back to part 4 of your notes. You can find this page, right? Sometimes, like when I was in high school and college, I would also date the notes as I did it. So because you're watching this online, who knows what date you're actually recording this, okay? So let's talk a little bit about the name. So as I was saying before, every atom has a name that includes a word part of the name, just like most of us have only a word. Mine is Jeff McManus, 2 words. I have a middle name too, of course. But some of you have numbers associated with your name. Have you ever heard of John Smith III, right? Well, every atom has a number associated with it as well. So you don't want to be incomplete, all right? And I'll show you why it's so important to know the difference between some atoms that have the same name but different numbers, okay? So let's talk about the name part. The word part of the name is based on the number of, you okay with me using that symbol there for number, I hope? The number of protons. Okay, so every atom has a certain number of protons, and we call that its atomic number. It's a really important number for every atom. It determines so much important stuff. So you have to know what atomic number means. I want you to underline that. If you have a highlighter or something, I want you to highlight that, because that's a definition you are going to have to internalize, okay? And it's actually a really easy definition. Every atom's atomic number is just the number of protons that it has, okay? So for example, this one here, the atomic number of that atom would be 20, because it has 20 protons. Again, that was from part 3 of the notes. All right? So just so you know, the word is not the same as the atomic number, but we need the atomic number to figure out what the name is. The word is found on the periodic table. Now, I'm not going to have you write a definition for that. I just want to make sure you can use the periodic table. So let me show you a couple versions of the periodic table that you'll have access to online, and I'll show you how to use that table to figure out what the word part of the name is. So let's take a look at the first and not so helpful diagram for the periodic table. All right, so what you're looking at here is a form of the periodic table you'll probably almost never see, but it is the actual proper arrangement, okay? And it's hard to see because it's so tiny and it's really long and wide, right? So that's not a very convenient form. So I'm going to show you a different form where all of this chunk here in the middle, there's 14 boxes there. We kind of pull those down to the bottom and we can squeeze the rest of it together. Much more familiar form. But then I'm going to be able to show you a little bit more exactly where these words are that we need to be able to name our atoms. Okay, well here's a more familiar form. So do you notice here this little box, 57 through 71 and 89 through 103? Those were pulled down and they were parts of rows 6 and 7, and so they're still labeled here 6 and 7. But now we can stretch them along underneath the rest of the table, and all of this stuff over here, these first two columns on the left, they can squeeze in, and it's a lot more, I guess, easy to manage shape. So we can make posters out of these. This particular one we find online is really convenient for us to use. So let me show you what we mean about the atomic number, helping you find the word that you need for the name. So up here, I want you to notice right above the second column is where we have the number. Let me find my mouse here. Sorry. So here's where we find kind of a key for what everything is. So the top number on all of these boxes is the atomic number. And the symbol is right below it. And here the name, and this is what we need, this is the word we're looking for, is the third thing in each one. So you'll notice the atomic numbers are all whole numbers, okay? Whole numbers. 1, 2, 3, 4, 5. There's no decimal numbers because you can't have like a small fraction of a proton, all right? So I use this example here of the 20 protons in that atom. So if we can find atomic number 20, and we read this just like a book, we start from the upper left and we go over, here's number 2, and then we go back here to number 3, 4, and then we way over here, 5 through 10, and then 11 through 18, and finally here, 19 and 20. So I found atomic number 20, and then on the third line in that box is the word that we need. That's calcium. So every element, every atom, rather, that has 20 protons has an atomic number of 20 is going to be called calcium. Okay? Now there's still something else that we need to include. Remember, every name includes not only that word, but a number as well. Not the atomic number, because that gives you the word, but it doesn't give you the rest of the name. And I'll talk about that next. Okay, so let's talk about this other number that we need. The number part of the name is called the mass number. Which is equal to the sum, which is another name for total, the sum total of the protons plus neutrons in the atom. Let you write that, and then we'll talk about what that means. Pause if you need to, but I'm going to flip this over just so I can remind you of the atom that we were talking about last week, or last time together. So here we had 20 protons, 19 neutrons, 20 electrons. It turns out the electrons have no part in the naming, okay? So we said before that the protons determine what the word part of the name is. So we would go to the periodic table, find element number 20, atomic number 20, and it's called calcium. But then the number that goes next to that is called the mass number for that particular atom. And for this one, the mass number is 20 plus 19. All the protons and neutrons that you have in the nucleus add up to be what's called the mass number. Remember, too, that the protons and neutrons are the only part of the atom that have any significant mass. The electrons are really, really tiny and don't really contribute much. So that would mean for this atom here, when I look at the nucleus, that's a total of 39 particles that have mass. Okay, so that would be the mass number. All right, so this is how we get the two parts. Let me go back to the 4 atoms that we drew last time together, and we'll now add a name for each of them so we can kind of have the complete picture. All right, so I'll give you a moment here to write down these 4 examples. These were the 4 for the atoms that we drew last time together. So we know what these look like when we draw them, or at least, they're a representation of them. Remember, our pictures of atoms don't exactly match what they would look like if we could see them in real life. So once you get these down, go ahead and start the video again, and I'll show you how to figure out what the name is. All right, so let's start with this first one. 1 proton, 2 neutrons, 1 electron. Remember, the electrons have nothing to do with the naming. All right, so we start by looking at 1 proton. And what does that mean? This is where you have to go to a periodic table, so I'll bring one up here. That 1 proton means we're looking for the atom that has an atomic number of 1. And on this periodic table, that's the number right on the top. It's always going to be a whole number, no decimals or anything. So it's the first one on the table, right there. So we need the name that goes with that box. In this case, it's called hydrogen. So that's how I'm getting hydrogen. And of course, you've heard of hydrogen, one of the more common elements in all of the stuff that we live in. In fact, you are made up a ton of hydrogen. But don't stop there, because there are different types, if you will. It'd be like a family where everybody's got the same last name, but maybe there's cousins and brothers and sisters, and you got to specify which one you're referring to. So now we want to see the total number of protons and neutrons. That's referred to as the mass number. So it's 1 proton plus 2 neutrons for a total of 3. The mass number is 3, and that we put after a little dash. So any atom that has those things in it is considered hydrogen 3. All right, let's look at another one. 5 protons, 7 neutrons, 5 electrons. So back to the periodic table, 5 protons means atomic number 5. So we go across here in order. There's 1, 2, 3, 4, then we have to go way over here. Atomic number 5 has the word boron. Okay, so all of the atoms with 5 protons, we say, has the name boron. Those are all part of the same element family. But which boron is this? Well, we've got to look at the mass number now. 5 protons plus 7 neutrons is a total of 12 particles with mass. So that's a boron 12 atom. That would be its name. Okay? Why don't you try the next one? Pause here, see if you can figure out, and you'll have to pull up a periodic table as well. You can pull up the one I was using if you wish. It's actually just ptable.com, but there's a lot of periodic tables, and they all do look a little bit different. If it confuses you looking at a different one, you certainly are welcome to pull up that. Go ahead and pause now and see if you can figure that out, and then we'll restart it. All right, so 8 protons. That means we're going to have to look for the atomic number 8 on our table. Just a little bit down from boron, right? Here's 6, 7, here's 8. Very familiar name, oxygen. Now, the mass number, again, we're not looking on the table for the mass number. You're not going to find it. Now, you will find YouTube videos where there's even a teacher or somebody making the mistake of telling you you can get the mass number off the periodic table. It's not there. The mass number is a whole number. It's a countable number. It's not a decimal number. Okay, so let's go back to what we know about the mass. 8 protons and 10 neutrons makes 18 particles that have mass, or a mass number of 18. All right. Our fourth one, the one that I was referring to earlier, 20 protons. We go to the periodic table. You might remember I said this a little bit ago. Here's number 20. That's the name calcium. Okay, and which calcium is this? And please get the spelling right. You can read it right off the internet there. Remember, we added up our protons and neutrons, and they added up to 39. So that atom there would be called calcium 39. And for our last one here, I thought I'd show you something a little bit interesting. Just like I talked about, you can have cousins with the same last name as you, but you're not really the same. So what do we do with 20 protons? Oh, sorry, I miswrote that. That was identical. 20 protons. What if we have 21 neutrons and 20 electrons? Okay. So because it's the same number of protons, it's the same element. Okay. On the periodic table, you'd still be finding element 20. That's still called calcium. But now the mass is 20 plus 21 for a total of 41. Calcium 41. All right. One of the reasons I wanted to bring this up was because these two, you might call them cousins of each other. They share the same name because they have the same number of protons, but they have different masses. And we have a name for that, and I'd like you to know the name. This is the last thing we'll do here today. Those two atoms are considered isotopes of each other. Here's what that means. They have the same atomic number. That means they have the same protons, but different mass numbers. Such as calcium 39 and calcium 41. Notice I have a little dash. Okay, the name includes two parts. There's the word and then a dash and then the mass number. Okay. All right, so recognize when you see atoms like this that they look like they're the same thing, but there is a slight difference. All right. Okay, certainly enough here, and you're going to get a little practice with this, but then you will be able to figure out the name for any particular atom that you would see or maybe draw. Okay. All right. Thanks for watching.